An introduction to the cosine law. So we're going to take a look at a satellite that sends GPS signals to two buildings, and we know the distance between the building and the satellite in both cases. How far apart are the two buildings? So what we're looking for is this distance right here. Now I'm just going to make this diagram just a little bit bigger, a little bit more extreme here so I can illustrate why or why not we can use the sine law. So this is 2.1 degrees. We know this is 350, and we know this is 370. So when we use the sine law, we're looking for a pair, a side and an angle that we know. So here we don't know the side. For 350, the angle opposite is this one right here, which we don't know. And for 370, the angle and the side link like this, and we don't know the angle. So there is no pair where we know both pieces of information. So that means the sine law is out of the question. And for that matter, so is SOHCAHTOA, because we don't have a right triangle. So there's no right triangle in this. That means we need to introduce a new law, and that's going to be called the cosine law. So the cosine law is aptly named because it has the cosine in it. And notice it's a more complicated law than the sine law. And so if you have a choice, you should use the sine law if you've got a problem where you can use it. But as established from the last slide, we can't use the sine law. So here we go with the cosine law. What I'm going to do is start by labeling the triangles. So this is the side we don't know. And I know the cosine law says A, B, and is using A, B, C's, and A's, but what I want to train you and for any problem is to be able to manipulate that formula for any letters. So I'm going to call this D, E, and F. So we're looking for little d, we know little e, and we know little f. So how do we transfer that information into this formula? Well, notice that the only place where there is an angle is angle A. And the only place where we know an angle is angle D. So in this formula, I'm going to replace that A with a D. So if this is a D, notice the similarity here. There's an A here and an A here. So if there's a D here, it must be a D squared here. Next step is to say, all right, these are the two other sides of the triangle. So we've used up D, which means we've got E squared plus F squared minus, here we go again, they're the same ones as B, these two. So it's minus 2EF. So I've transformed the formula that you'll see on your formula sheet to suit my triangle, which is labeled DEF. This should have been capital here, just checking that out. Now, that's how we relabel, and that's just the first step. And if we now plug in the values, we would get capital little d squared equals e squared, which is 370 squared plus 350 squared minus 2 times little e is 370 times little f, which is 350, times the cosine of angle D, which is 2.1 degrees. So I'm just going to leave that there for now because I wanted to just practice manipulating the formula, and we'll move on and practice this some more in the next skill. So really the one important thing to know is when can I use the sine law or cosine law? And remember, we're looking for the pairs. So if we know a combo of pair and opposite side, then we use the sine law. So here, I don't know little e, unfortunately. Here, I don't know f, and here, I don't know d. So there's no pair, which means I use the cosine law. Let's try that again with the second triangle. Oh, look at this, I've got a pair. That means I use the sine law. Going to the bottom left here, I don't have B, I don't have C, and I don't have little start big A. So again, this one is going to be the cosine law. And last example, here I've got a pair, which means I need to use the sine law. So hopefully that helps distinguish where you start with a problem. So now we're going to dive into the next skill on actually solving using the cosine law.